We made Pawnsy a chess social media platform to learn, analyze, and discuss chess content. Once you log in, you can access the various features of the website. For example, here, you can make posts about various chess topics, such as meeting up in person to play chess in real life. Afterwards, you can access the various other features of the website. For example, here, you can play against a very good bot called Stockfish. After that, you can upload your chess game and analyze the game you just played by moving through with the arrow keys. This is the third version of our proposal, and as you can see here, we have our various big ideas, such as 1.3, front-end to back-end integration, where all of us work to make APIs that connect to the front-end, and back-end debugging, where we fix the various schemas and issues that came up. Here you can see our burn down and various rates that they occurred at, and from this we can see that we must be more efficient in the future. Lastly, this is our project structure, where all the things are organized neatly so we understand what tasks to be done. Here you can see our Kanban board where we did our various iterations and planning, where we broke each step down into its various subtasks so everyone understands what they need to do with clear checklists. Lastly, here's our Figma where we did some also visual design to understand what to create on the front end. This is my feature. I made the chessboard for our website Pawnsy. Essentially how this works is on the back end, we have a REST endpoint called /getMove, which is where the endpoint it takes the current board's position and represents it called something called a fence string. This fence string is then passed to the Stockfish engine, which is queried on the front end to then be displayed to the user, and I'm allowed to play it as I can see here. This is my user's story. The goal is to create a chessbot that the user can interactively play with. The next steps are to create multiple difficulty levels of Stockfish. Lastly, here you can see my burn down of the various tasks I've completed throughout the sprint.
Let me show you the chess game analysis feature on Pawnsy and how it works. The code initializes the chessboard with chessboard.js and listens for PGN file uploads using handle file upload to parse moves with chess.js. The update board function resets and replays moves based on the move index, while arrow key navigation updates the board dynamically using fence strings. You can navigate through moves with the arrow keys, and the board resets and rebuilds each position in real time to match the move index. Discussed, this is the list of objectives completed as well as to be completed, which will have an accuracy feature that compares the fence strings of actual gameplay to the best possible move at the time.
I've created a leaderboard with players arrays where each object has a name and number of wins. This sorts the players by win function and builds a podium for the top 3 players based off their wins of that week. JavaScript is used to fetch the players' data from the backend in order to update the leaderboards weekly. In my personal story issue, I explain the overall structure and idea I want to implement into the website, as well as my checklist of completed and in-progress items, like leaderboard, buttons, fixing 404 errors, and additional features we'd like to add.
For my work on Pawnsy, I focused on 3 key ideas. I implemented a sleek black UI with hover and bounce animations that meet CPT requirements 1.3 for a visually appealing front end. The loading bar tracks application performance and touches Big Idea 4 monitoring and logging. To dynamically display users online, I created an endpoint that handles data parsing and storage. This meets CPT 1.3 requirements through efficient front-end and back-end integration. Finally, this is my burn down as well as my tasks all completed and my type error when retrieving data resolved.
Hi, my name is Vasanth, and that right there was a chatbot named Pawnsy that I created using Gemini integration. Here, a post request is made and is sent to the database that is constantly being updated through an asynchronous function. In the future, we'd like to perform GET requests to allow the users to access their past chats. In the future, we'd like to change our schema to better organize our database. To keep track of my progress, aside from my team's overall Kanban board, I've created my own burn down list that I check off as I complete tasks that are relevant towards my story.
My feature involves creating different pages depending on whether a user is logged in or not. Upon login, users will see our full homepage. When logged out, they'll see this, only prompted to be logged in. This is the code that I used to create this feature. The code checks if a user is logged in by calling the backend API endpoint API/user and fetches user details using the predefined settings below that I gave it. If the response is valid, it will return the user data and display the contents of the page. Here's a burn down that I created to keep track of future iterations as well as past and future goals.